So you can say that the collection is means the group. Okay. So a collection API means there are some classes interfaces that provides you to store more than one object in a single entity. Fine. Or if you heard about the data structure that we implement using the C++, like linked list, tree, hash table. So all these things are by default implemented and by default available to use in Java in the form of the collection. So what is collection framework? A collection framework provides a well-designed set of interfaces and classes for storing and manipulating groups of data as a single unit. Groups of data means a collection of students record, collection of items that you want to purchase. So you can put all those value in a single unit that we call collection. It provides a convenient API to many ADT like maps, sets, list, trees, arrays, hash table, and other collections. ADT, you have already, I hope you have already learned in C and C++. It is called abstract data types. So you don't need to create, even you don't need to write, and you don't need, even you don't have to bother about that how these things are going managed by your Java. So all the things is like map, set, list, trees, arrays are by default available. You just need to use it. And all the classes and interfaces of collection API are available in java.util package. So make sure that whenever you want to use any collection class in your code, then first of all import java.util package. And this is the collection framework hierarchy that you can see here. The java.util package contains one Java's most powerful subsystem as a collection, and collection were added by the initial release of Java 2. Java 2 means from 1.2 it is available, and in every version it get enhanced. So just look at here and understand the hierarchy. As you can see, there is a table, and after that the collection, and then you can separate this collection into three parts, that is list, queue, and set. As you can see, um, all the thing that is written into this box are interfaces. Okay, and all the things that is written into this box here are classes. Just look at here. So these are interfaces. Iterable interface, collection is interface, queue and list and sets are interface. And from here we have the array list, linked list, vector, stack, and tree set, hash set, linked hash set. So there are so many classes that you can use in your application. And as we know that one class can extend another class, one class can implement another interface. So by seeing this image, you can identify that which one is extending and which one is going to implement. The main work, why I'm discussing this hierarchy, because you should know which one is the parent and which one is the class, because we know one term in the dynamic programming, dynamic polymorphism, that parent reference can hold the child's object. So if you create any object of the array list, that can be hold into the list reference, that can be hold into the collection uh, reference. So that's why this hierarchy is important. And whenever you want to implement and you want to use any collection, you only need to create the object of the classes. Why we will create the object of the class? Because we can create only the object of the classes. We cannot create the object of interfaces. To implement this, you need to create the object of these classes. So why there are so many types of the classes are available? So as we know that there are so many types of data structure implementation is available. For example, there is one data structure implementation that is called stack, and it works on uh, that is first in last out. Okay, or you can say the last and first out. So this is the implementation technique. And we also know that there is a queue that works on first in first out. So this is the mechanism of implementation. So if you want that the values that you want to put into your collection works on some um, data structure implementation, then you will create that type of object, and all the things are implemented through the class. Now just look at here, this interface, that is the collection. And one thing you will find that in collection there is e mentioned. Okay, so um, don't bother about it, and don't think right now, don't think about it that what is e. I'll explain that what is e and how to use it. Only just understand that this is only a simple java.util.collection. Okay, so this is the super interface for all classes that define the collection and define the most fundamental behavior of every collection object. Fundamental behavior means the method that are common for all classes. Because collection extends iterable, all collection can be cycled through the for each loop. Collection interface implements this iterable, and remember this point that iterable interface is not a part of a util package. This is the part of your java.lang package. Okay, so actually the collection starts from collection interface. The hierarchy starts from collection interface. This iterable interface provides the for each to iterate the objects. Okay, to iterate the group of elements, so that we can iterate any collection object by using the for each. And here you can find uh, the definition of the iterable and iterator. Okay, so here you can see that the iterable interface that is in java.lang package has one method that is called iterator. And this iterator, whenever you will use, okay, so I hope you are getting this point that if this interface is extended into the collection, then every collection will have the iterator method, because it will come from this interface to the collection, and after that it will be available to all subclasses of this collection type. So iterator is available in every collection, and when you will call this, then it will return one object of type iterator. Just look at here, it will return one object of the iterator. And when you get the object of the iterator, then what you can do, just look at here, one interface is the iterator has three methods, that is has next, next, and remove. So you can use these methods on any on any collection. So definitely, if we get the object by calling this method, then we can call the methods of iterator interface by that object. So this is one thing that you should remember, because sometimes this gets and make the confusion that how we are using the iterator and how we are using the iterable. Another thing that is, this is the table that you can find here. there are so many methods, okay, that is provided by your collection interface. In the previous slide that we have seen that uh, defines the most fundamental behavior of every collection object. So what are those behaviors? We'll see. And these are the fundamental behaviors. And as we know that in interface, we cannot define any methods. So every class of the collection implements these methods as per the implementation point of view, that in which order the value should be added, in which order the value should be deleted, where we can add, where we can manipulate. And as we have already done in data structure, that in a stack the only thing you can do is you can add any element from the top, and if you want to delete any element, then you can delete the element from the top. This is the mechanism of stack. And when you talk about the queue, then you can see that we can delete the element from the front, and we can add the element from the rear. So this is the mechanism of queue to implement. And so methods, these methods are by default provided by the collection interface, and how your collection will work will be implemented by every specific collection. So one method is called add. So this add method will available on in every collection. This method works as to add a new element to the collection. And remember this, in collection, whenever you want to add any element or any new uh, object or value, so that must be type of object. You cannot add any primitive type of the value into the collection. So adds object to the invoking collection. Invoking collection means, just look at here. Invoking collection means that collection could be type of array list, linked list, stack, tree set, hash set. So it could be anything. So according to the object, it will add that element to that collection. Returns true if object added to the collection. Maybe the object is not maybe not added to your collection, then it will return false. If it gets added, then it will return true. Um, if you have already one collection that has suppose 10 elements, then you want to add those 10 elements into another collection in one go. So what you will do, there is a method that is called add all. So here you can see that you can pass any object that is the type of collection. So it will add a whole value into the existing from the existing collection object to the new collection. If you want to drop all the elements, then you can call the clear method. To check whether the particular collection containing a specific type of element into it, then you can use the contains method. And remember, you will pass object, okay, to check if that element is available into the collection, then you will get return true, otherwise you will get return false. Contains all, definitely you can check that if one collection's all elements are available into another collection, okay, so then it returns true. To check this type of operation, you can call this thing, okay. Equals to check that collections are having the same elements or not, then you can use the equals method, and here you can pass the object. Is empty to check whether any elements are available into the collection or not, then you can check is empty. If the collection doesn't contain any element, then it will return true. Iterator to iterated to fetch elements one by one, then we use the iterator. To remove any element from the collection, we use the remove method, and we pass the object that we want to remove. Remove one instance of object from the invoking collection. Returns true if the element was removed, otherwise returns false. Remove all and the collection. Suppose you have one collection and you want to remove um, multiple values that is available into another collection, then you can pass collection over here. So you can remove in one go one collection's element from another collection. Retains all means this is method that where you will pass one collection, and if you call this method, then it will retain all the elements that those are common into calling collection and the collection you are passing. So you can say that remove all the elements which are distinct. So remove all elements from the invoking collection except those in C. Returns true if the collection change. Okay, and otherwise it will return false. Integer size to get the size of the integer, collection object. So to get the size, we call size method. To convert into the array, we can call the method toArray. And as we know that in every collection, we have objects. So it will return the object array. To convert into the array, we call object and toArray. Object toArray and object array you can pass. So it will return into the object array. So this is the array that you can pass to convert into the object array. To get the hash code, we can use the method integer hash code. So these are the method that is common to all collection. And look at here that the collection hierarchy. There is a list, there is a set, and there is a queue. Um, are interfaces. So let's see that what is the list and what is the set and what is the queue. Come here. So as we know that we cannot create any object of list because this list is interface. So we can create the object of the list type classes. So ArrayList is the type of the list list interface. So declares the behavior of a collection that is stores a sequence of elements. Sequence of elements means whenever you store any value, that value will be stored into sequence one by one. If you store one value, then first value, then it will go into the onto the 0th index. Then after that, it will go on first, second, and third. So this is the way that it stores the values. Elements can be inserted or accessed by their position in the list. So list provides one facility that if you want to insert the element at the specific position, then you can do this because list provide this facility. And if you want to access any element from the specific position, then you can access it. Why? Because this collection type stores the value in the sequence. Sequence means on the basis of index. So obviously, whenever you will add any new element, then it will create the sequences and indexes. So you can perform this operation on the basis of position also. In list, one important point is in list you can add duplicate elements. Okay, if you have already added one object and want to add one more time, then you can add that object into the list because list contains the duplicate objects. So here is one more time, just look at here the hierarchy, iterable collection and the list. And also list provides some extra methods, some other implemented methods. These are the methods, just look at here. These are the methods which are common for all collection, but these are the methods, means there are some more methods which are not common for all the collection. This is that you are seeing here. Okay, so these are only for the list type collections. Okay, so add, and here you can pass one index where you want to add and the object that you want to add. And this method is not available into the set. Okay, just look at here. The add method is available for all collection, but here you only pass the object. But in list, you can use one more add method. There is a overloaded method, so you can pass index also. And add all, so you can add all method you can use. There you can pass the index where you want to add the existing collection into the collection. And there is one more method to get the value from the index. You can call the method get, and you want to get the index of any object, then you can call index of method. And as we know that list can contain duplicate elements, so if you want to get what is the last index of any duplicate element, then you can call the method last index of, and you can pass that object. And these three methods, just look at here, these three methods, if the that index you are passing, and if element is available at that index, then it will return that object. If not, then it will return -1. If you want to get the index of that object, that here, and that object is not in your list, suppose you have added so many objects in your list, but you want to get the index of any object that is not available, then you will get -1. So the same case with the last index of. So basically, in collection, there are so many methods that you need to learn, and only you need to use. One more, there are some more methods that are available into list. In every collection, you will find iterator, but in list, this is a specific implementation of the list that is called list iterator. So you can call the list iterator, and after that you will get the list iterator object. So this is also one thing that you can do to get the values one by one. Iteration means fetching the value. Okay, and list iterator and list provides you some more thing, like suppose you have 20 objects in your list, and you want that uh, the iteration should be start from 5th index. First 4 index should not be iterated. So what do I mean to say is, just look at here. Suppose this is your collection, and in which you have added so many elements. So as you know that every element will be at some index, because it provides the indexed. As you will add, it will add the value, and it will increase the indexes. So if you use the iterator, so iterator will always start from the 0th point. Okay, and it will go from 0 to the end. If you use the list iterator, then you can perform the same operation. But in list iterator, you can see here, in list iterator, I can pass the index also. So we can specify that the iteration should start from this index or in this index. So you can pass the indexes also. So this is the implementation of the list, not from the set, because we are talking about the list, not the whole collection. Okay. To remove any element, we can pass the index also. So that object will be removed, and you will get the remove element as return. And if you want to set any element at particular index, then you can call the set method. And here you can call the method by passing two values. One is your index, and second one is your object. Suppose this is your collection that is already created. You want to insert a new element at this index. So you will pass the index number 2 and the object that you want to insert. So it will be inserted at index number 2, and it will increase your size, and it will shift one by one index forward. You can also get the sublist from a given list. Suppose this is your list and you want that this should be one list. So you can pass the starting index and the end index from and to. So it will return a sublist from a given list. Just look at here. So sublist, if you want to find, then you can pass the starting index and the end index. So these are some methods. And list iterator that we have already seen. So list iterator actually extends the iterator. So definitely the methods which are available into the iterator will be available into the list iterator. And what are the methods which are available into the iterator? Just look at here. These are the methods which are available into the iterator. So has, next, next, and remove. These methods are available into the list iterator. Plus, look at here. Plus, some more methods are added into the list iterator. So we have seen that has, next, next. Okay, so it also provides has previous. Okay, so as I said, if you use the iterator, then you will start the fetching the element from the starting, from the 0th index to the end index. But what if we want to fetch the element in reverse order? From 6 to 1 or 5 to 4, I want to get the element in reverse order. So if you want to iterate the list into the reverse, then you can use this one, that is the list iterator, because it provides methods that is has previous and the previous. Okay, so these are some methods which are available into the list iterator. Now come to this class, and since we know that we can create only the object of the classes, we cannot create the object of the interfaces. So the main concern about writing the code is create the object of the class. So the very common and the most used collection in the coding is ArrayList. Okay, the ArrayList is very simple and very effective. The Java ArrayList class uses a dynamic array for storing the element. And why we say that the dynamic array, as we know that if we declare any array, that we cannot increase and decrease the size of that array um, at runtime. Okay, so if you want to add some element at runtime, and if you want to remove that element at runtime, then you can use the array list. So this is the dynamic array. Java ArrayList class can contain duplicate elements. Yes, of course, because the list can contain duplicate elements. Java ArrayList class maintains insertion order. Insertion order means the indexes 0, 1, 2, and so on. Java ArrayList class is non-synchronized. Just remember this point, this class is non-synchronized. And Java ArrayList allows a random access. Obviously, it provides the random access because array works at the index basis. And also, the ArrayList class, just look at here, the ArrayList class implements these interfaces: random access, clonable, and the serializable. So these are the interfaces that provide the extra functionality to the ArrayList. Random access provides the functionality to access any element in randomly. Clonable, that you can create the duplicate and the clone object of this ArrayList, and the serializable means you can perform uh, or I can say in one line that you can write this object onto the file by using object input stream and object output stream. So we can save whole element onto the file, or we can send the values from one place to another place by using the array list. So just look at here, what are the methods that we can use and how to use the array list. So here we can create the array list object by using new array list. Here is list A1. I hope this statement is clear. List is the parent and array list is your class. So we can write that the list A1 is equal new array list. List A2 is equal new array list. Parent reference object, child's object. So if I add that A1 dot is empty, okay. So there is a method that check uh, whether the collection is empty or not. So what will be the output? Definitely the output will be true because there is no element in the collection A1, that is array list. If we use the method that is A1 dot size, since we don't have any element into the A1 and don't have the element into A2, so it will return the size as 0. Now add the element as India into your array list A1. So after performing this operation, what it will return? It will return true because it returns true or false. So now this will add into your object A1. So now you can see that A1 has one element, that is India. Another is I want to add another element, that is China. Then add the element as Nepal. So we can add as many number of element into the A1. Okay. Now I'm going to add the element into A2. Okay. So A1 has the objects India, Nepal, China, USA, like this, and A2 has these elements. Now, if I write the A1 dot remove Japan, then look at here. What will be the output? It will return the false because A1 doesn't contain the element, that is Japan. So remove element, we can pass the object, and that object must contain into that collection. So this collection doesn't contain this element, that it will return false. And if I write that A2 dot remove Japan, let's look at here. Since this array list 2 has the element Japan, then it will remove the Japan from here and it will return true that the operation performed successfully. And these methods we have already seen in the previous slide. And just look at here. If we want to check whether any collection contains the particular object, then we can use the method contains. So A1 dot contains India. Just look at here. Yes, this contains. We can see this because we have created the graphical representation. But in program we will write to check. So it will return true. But in array list 2 there is no object India. Then it will return false. Again, if we want to perform the bulk operation like A1 dot contains all array list 2, okay. So just look at here, A1 has India, Nepal, China, and USA, and A2 has the Nepal and China. Does A1 contain all the elements of A2? So yes, Nepal is here, China is here. So check whether the elements of another collection is available into any collection or not. We use contains all. So just look at here, it will return true. Okay. And if we write that A1 dot remove all A2, so it means remove all the element which are in A2 from this array list 1. So it will remove, and you can see here it will return true because all the elements of this are available and removed. So only the India and USA is remains into array list 1. So this is the bulk operation we are performing. We are deleting more than one object in one operation. And again, what I'm going to do, I'm going to write the method that is retain all. So it says that retain all the elements of array list 2 which are available into array list 1, and except these remove all the elements. So a array list 2 has Nepal and China, that you can see. So if array list 1 has the Nepal and China, then it will retain these and rest of the object will be removed. Just look at here. Only the common elements retains. Again, this is one more method that is clear. So if I call this, then every element of this these collection will be removed. So these are the method that we use to perform the operation. Okay. So in program, how to write the code? You can write the code by this. You can create a class And after that, you can create main method. Then we create any object of the array list. We can add the elements here, and there is a class that is vector dot add all, and what we are going to add, that is array list. Then it will add the new element. So this is the hash set reset. So when I'll discuss all these classes, then we'll come to this example. But I hope the previous example that we have seen, that is how to clear, how to retain the elements into the collection. So these are the methods. Just tell me any doubt till now. Okay, good. Uh, from very first, I'm saying that in collection you add only the objects. An object could be any class object. For example, if you want to add a string, so a string is a type of object. Okay, if you want to add um, any value that is one, for example, and one, as we know that it is int and it is a primitive value. So first we'll convert into the object by using the wrapper class, and then we'll add to the collection. Collection doesn't contain any primitive value. It contains only objects. Yes, ma'am. And uh, as I said earlier, just look at here. Where is that? I'll go there 1 second. Just look at it. This E that you can see here. Okay. So as I said, just wait for a moment. I'll explain that what is E. Okay. So till now, only the objects can be added to your collection. Fine. So that's all for today's session. That this is the one introduction of the collection. In the next session, we'll see in detail that how to iterate and how to use the collection in our application. If you have any query, any doubt, then you can put your query into the chat box.